Today, we're going to discuss integrals involving powers of secant and tangent. So the following guidelines can help you evaluate integrals of the form the integral of secant to the power of m of x times tangent to the power of n of x dx. So number one, if the power of the secant is even and positive, then save a secant squared factor and convert the remaining factors to tangent. Then expand and integrate. So we have the guide here. So the integral of secant to the power of 2k of x times tangent to the power of n of x dx is equal to the secant squared of x to the power of k minus 1 times tangent to the power of n of x times secant squared of x dx. And that can be now written as the integral of 1 plus tangent squared x to the power of k minus 1 that is coming from the identity of secant squared x, then times tangent to the power of n of x secant squared x dx. So number 2, if the power of the tangent is odd and positive, then save a second tangent factor and convert the remaining factors to secant. Then expand and integrate. So we have here the guide. So the integral of secant to the power of m of x times tangent to the power of 2k plus 1 of x dx is equal to the secant of m minus 1 of x times tangent squared of x to the power of k times secant x of tangent x dx. So is equal to the secant to the power of m minus 1 of x times secant squared of x minus 1 to the power of k times secant of x tangent x dx. Take note that is 4 if the power of the tangent is odd and positive. And number 3, if there are no secant factors and the power of the tangent is even and positive, then convert a tangent squared factor to a secant squared factor, then expand and repeat if. So we have here the tangent to the power of n of x dx is equal to the tangent of n minus 2 of x times tangent squared x dx is equal to the tangent of n minus 2 of x times secant squared of x minus 1 of dx. Then number 4, if the integral is of the form of secant to the power of m of x dx, where m is odd and positive, then use integration by parts. And number 5, if none of the first 4 guidelines apply, then try converting to sine and cosine. Now let us try example number 1. So we have here, since this is just a continuation, so we have example number 8 is the integral of secant to the power of 9 of x times tangent to the power of 5 of x dx. So in this kind of example, we're going to save factor of secant x tangent x. So therefore, we can write now the given as secant to the power of 8 of x times tangent to the power of 4 of x times secant x tangent x dx. Next, we have to write now as secant to the power of 8 of x. So we're going to factor out the tangent to the power of 4 of x, and that can be written as tangent squared of x to the power of 2 times secant x tangent x dx. So we can write now as secant to the power of 8 of x. Now, the identity of tangent squared x, which means secant squared x minus 1 the power of 2 times secant x tangent x dx. So from there, I'm going to let u now equals secant x and du, which is secant x tangent x dx. So rewriting the given now in terms of u and du, so I can write now as u to the power of 8 times u squared minus 1 to the power of 2 times du, because du means secant x tangent x dx. So next is that we're going to expand the square binomial. So we can write now u raised to 8 times u raised to 4 minus 2u squared plus 1, then du. Then after that, using distributive property, So we can write the product as u to the power of 12 minus 2u to the power of 10 plus u to the power of 8 du. Now, we can easily integrate that given. So we can write now as u to the power of 13 over 13 minus 2u to the power of 11 over 11 plus u to the power of 9 over 9 plus a constant. So rewriting now the meaning of u. So this is now equal to secant to the power of 13 of x over 13 minus 2 secant of to the power of 11 of x over 11 plus secant to the power of 9 of x over 9 plus a constant. So next we have here the integral of secant to the power of 4x times tangent to the power of 6 of x dx. So in this kind of example, we are going to factor out the secant to the power of 4x. So we're going to write this one now as the integral of secant squared x times tangent to the power of 6x times secant squared x dx. And then we are going to use the identity of secant squared x, which means that is tangent squared x plus 1 times tangent to the power of 6 of x times secant squared of x dx. So from here, I can let now u as tangent x and du is equal to secant squared x dx, which is now visible in our given. So rewriting now the given in terms of u and du, so I can write now as u squared plus 1 times u to the power of 6 times the meaning of secant squared x dx is now du. So next, we are going to use distributive property. So we can now have the integral of u raised to 8 plus u to the power of 6 du. So integrating that one will give us u to the power of 9 over 9 plus u raised to 7 over 7 plus a constant. And then replacing the meaning of u, we have now tangent to the power of 9 of x over 9 plus tangent to the power of 7 of x over 7 plus a constant. Number 10, the integral of tangent x dx. Although we have the direct integration for that, so let us try to derive the definition of the integral of tangent x dx. So we can write now first as the ratio identity of tangent x, which is now sine x over cosine x dx. So let u now equals cosine x and du now is the negative sine x dx. But in our given, we only have sine x dx. So therefore, we have a coefficient factor of negative 1. So rewriting now the given in terms of u and du, so I have the negative 1. The integral of meaning of sine x dx now is du. We have du over the meaning of cosine x is u. So therefore, we have now the integral of du over u. So integrating that one, we have the negative ln of the absolute value of u plus a constant. So rewriting the given again, negative ln of the absolute value of cosine x plus a constant. So you can stop here, or by applying the property of logarithm, so we can write now as ln of the absolute value of cosine x to the power of negative 1 plus a constant. And that is now ln of the integral of 1 over cosine x plus a constant, and then the meaning of 1 over cosine, which is now the ln of secant of x plus a constant. So either of the two answers are accepted. Okay, number 11 is the integral of tangent cube x dx. So in this example, we're going to factor out that one as the integral of tangent x times tangent squared x dx. So we can write now tangent x times the identity of tangent squared x is secant squared x minus 1 dx. And then using distributive property, so we have the product of tangent x secant squared x minus uh, tangent x dx. So separating the two terms, we can write now as tangent x secant squared x dx minus the integral of tangent x dx. So in the first term, we can let u equals tangent x and du here equals secant squared x dx. Since the second term has a direct formula, so we can just now write as equals the integral of u du minus the integral of tangent x dx. So the integral of u du is equal to u squared over 2 minus the integral of tangent x dx. So therefore, u is tangent x, so therefore this can be now tangent squared x over 2 minus the integral of tangent x. Now we have ln of secant x, so therefore minus ln of secant x, the absolute value of this, plus a constant. Number 12, we have now the integral of secant cube x dx can be written as secant x times the secant squared x dx. Since the function here are the same, we have secant x and it's in a product form, so it's better to use now the integration by parts. I will identify my variables as uv. Our u there is secant x and dv is the remaining terms, which is now secant squared x dx, and then our du is equal to secant x tangent x dx, and v now is the integral of secant squared x dx, which is now tangent x. So by writing the formula of integration by parts. So I have here equals to uv minus the integral of d du. So writing that one, the product of uv now will have secant x tangent x minus the integral of v du, which is now tangent x times secant x tangent x dx. So copy only the first term of secant x tangent x minus multiplying that one will give us the product of secant x tangent squared x dx. And rewriting again the first term, which is secant x tangent x minus the integral of secant x, and the identity of tangent squared x is secant squared x minus 1 of dx. So simplifying again the second term, so I will just rewrite the first term first. So we have secant x tangent x minus secant times secant squared, we have secant cube x. Then secant x times negative 1, we have secant x dx. So rewriting this one again, so I will write first the original given, which is the integral of secant cube x dx is equal to secant x tangent x minus the integral now of secant cube x dx. Negative of negative secant x becomes now positive, the integral of secant x dx. Since this one is similar to the original given, so I will transpose that one, and that becomes now 2 the integral of secant cube x dx. Why 2? Because this becomes positive 1. So 1 plus 1 of secant cube x dx, it becomes now 2 the integral of secant cube x dx is equal now to secant x tangent x plus the integral of secant x dx. We have the ln of secant x plus tangent x plus a constant. But since we have a coefficient of 2 here, so we can now write the final answer as 1 half of secant x tangent x plus ln of secant x plus tangent x close plus a constant. And that is now the answer for number 12. Okay. For number 13, so we have here the integral of sine to the power of 7x over cosine to the power of 4x dx. So we are going to factor out the sine to the power of 7x as the integral of sine to the power of 6x over cosine to the power of 4x times sine x dx, because sine to the power of 6x times sine x is equal to sine to the power of 7 of x. Okay, so from there, I'm going to rewrite again the numerator. So that can be written now as sine squared x to the power of 3 over cosine to the power of 4 of x times sine x dx. So from sine squared x, we can write the meaning for that using the Pythagorean identity. We can write now as 1 minus cosine squared x to the power of 3 over cosine to the power of 4x times sine x dx. So from there, we can now write u equals cosine x, and du now is negative sine x dx. While the sine x dx is visible in the given, so therefore I have a coefficient factor of negative 1. So rewriting now the given in terms of u and du, so I'll start first with a coefficient factor of negative 1 times the integral of 1 minus u squared and then quantity to the power of 3 over u raised to 4 times the meaning now of sine x dx is du. Next is we are going to expand the cube of binomial. Okay, recall on the idea of cube of binomial. So we have the cube of a plus b is equal to a cube plus 3a squared b plus 3 times ab squared plus b cubed. Then in terms of minus sign, so the cube of a minus b can be written as a cubed minus 3a squared b plus 3 times a times b squared minus b cubed. Since our given is difference, so a minus b, so we follow this format. So rewriting that one, the negative of the integral of the product form now of the cube of 1 minus u squared can be written as 1 minus 3 times a squared times b. Therefore, a is 1, so 1 squared is 1 times b. Therefore, we have 3u squared. Then plus, using this pattern now, 3a times b squared, your a is 1, so times 3 is 3, times the square of u squared becomes now u raised to 4. So therefore, it becomes now 3u raised to 4 minus the cube of the last term. So cube of the last term, which is now u to the power of 6 all over u raised to 4 du. So after that, we are going to divide to simplify the integrand. So I will just write it here. So the negative of u to the power of negative 4 minus 3u to the power of negative 2 plus 3, and then the last term is minus u squared of du. So integrating this one now will give us the negative of the integral of u to the power of negative 4 will give us u to the power of negative 4 plus 1 is negative 3 over negative 3 minus 3u to the power of negative 1 over negative 1 plus 3u minus u to the power of 3 over 3 and then plus a constant. This will become now negative. Simplifying this one, we can write now 1 over negative 3 u to the power of 3. And then this negative 3 and negative 1, it becomes now positive 3 over u plus 3u minus u to the power of 3 over 3 and then plus a constant. Since I have negative outside, so I will multiply that one using distributive property. So the negative of negative here becomes now positive. So we have 1 over 3u to the third power. Then 1 times that is the sign now will be changed as negative 3 over u minus 3u plus u to the third power over 3 and then plus a constant. So finally, we can have now the answer of 1 over 3 cosine cube of x minus 3 over cosine x minus 3 cosine x plus cosine cube x over 3 plus a constant. So for number 14, we have the integral of tangent cube x over the square root of secant x dx. So first, we are going to factor the tangent cube x, and we are going to rewrite the denominator of square root of secant x in the numerator. So therefore, we can write now as secant x to the power of negative 1 half. And the factor now of tangent cube x, we have tangent squared x times tangent x dx. Since our goal here is to have a factor of secant x tangent x, so we're lacking of secant x. So where are we going to get that secant x? So we are going to get the secant x from the secant x to the power of negative 1 half. So therefore, I will just subtract the exponents of negative 1 half minus 1 half. Then it becomes now here as secant x to the power of negative 3 halves times tangent squared x times secant x, the one that we get out of secant x to the power of negative 1 half times tangent x dx. Now, I'm going to write the identity of tangent squared x. So I will write first secant x to the power of negative 3 halves times secant squared x minus 1 times secant x tangent x dx. So from here, I'm going to write now u as secant x, and du now will give us secant x tangent x dx, which is actually from the given. So rewriting now the given in terms of u du, okay, I can write now the integral of u to the power of negative 3 halves times u squared minus 1 times the meaning of secant x tangent x dx is du, therefore I have du. Now from there, we are now going to use distributive property. So the product of u to the power of negative 3 halves times u squared is equal to u to the power of 1 half minus the other term. We have u now to the power of negative 3 halves du. So by integrating this one now, will give us now as u to the power of 3 halves over 3 halves minus u to the power of negative 3 halves plus 1, that is now negative 1 half to the power of negative 1 half plus a constant. So by simplifying that, so we can rewrite that one now here as we have 2/3 of u to the power of 3 halves, negative and negative 1 half becomes now positive. So we have 1 positive u to the power of negative 1 half plus a constant. So by substitution again, the meaning of u, we have now 2/3 of secant x to the power of 3 halves plus secant x to the power of negative 1 half plus a constant. And that is now the answer of that problem. For number 15, we have the integral of secant to the power of 4 of 3x times tangent cube of 3x dx. So we are going to factor out the secant to the power of 4 of 3x. So we can write now as secant squared of 3x times tangent cube of 3x times secant squared 3x dx. So secant squared of 3x times secant squared of 3x will give us now the secant to the power of 4 of 3x. So next now is we are going to use the identity of secant squared x 3x. So using the Pythagorean identity, so we can write now as 1 plus tangent squared of 3x times tangent cubed of 3x times secant squared of 3x dx. So from there, we are going to let u is equal to tangent of 3x. Now, du will give us 3 secant squared of 3x dx. But we can only find the meaning of secant squared 3x dx from this given. So therefore, we have the coefficient factor of 1/3. So we're gonna write now 1/3 the integral of 1 plus u squared times u to the third power times the meaning of secant squared 3x dx is du. So we have now 1/3 times by using multiplication. So we can write now u to the third power plus u to the fifth power of du. So by integrating that one now, we can have 1/3 times u to the power of 4 over 4 plus u to the power of 6 over 6 and then plus a constant. So by using distributive property, so we can write now u to the power of 4 over 12 plus u to the power of 6 over 18 plus a constant. So therefore, the final answer now will give us uh, tangent to the power of 4 of 3x over 12 plus tangent to the power of 6 of 3x over 18 plus a constant. Okay, so that's now the answer. Okay, for number 16, so this is just quite simple. So just factor out the power of 4. So we can write now as tangent squared x times tangent squared x dx. And then one of the factors, we are going to write the identity as secant squared x minus 1. So we can write now secant squared x minus 1 times tangent squared x dx. Using the distributive property, so we can write now as the integral of secant squared x times tangent squared x minus tangent squared x dx. So by separating the two terms, we can write now as secant squared x tangent squared x dx minus the integral of tangent squared x dx. So in the first term, so let u here as tangent x, and the derivative of tangent x is secant squared x dx, which is this one. Okay, we're rewriting the given now, so we can write as u squared du minus, for the second term, we have the integral of tangent squared x dx. We are going now to use the identity. So we have the identity of secant squared x minus 1 of dx. So we can now integrate the first term as u to the power of 3 over 3 minus this one, the integral of secant squared x dx is equal to the negative of tangent x, and the integral of negative 1 dx times negative 1, we have now positive x plus a constant. So we will just change now the first term. So the u is tangent x, so therefore it becomes now tangent cube of x over 3 minus tangent x plus a constant. And that will be now our final answer for that problem. Okay, this will be my last example to this topic. Number 17 is the integral of secant x over tangent squared of x dx. Since the given is that we cannot apply the first four guidelines as stated on this slide, so therefore, we're going to use number 5. If none of the first four guidelines applies, then we are going to convert to sine and cosine. So let's try to convert it now. So we have, so this is now equal to the integral of 1 over cosine of x all over. So there is the ratio identity of tangent. We have sine x over cosine x. So we just write here the square of dx. So simplifying that one, we can write now 1 over cosine of x times, we are going to take the reciprocal for this, so becomes now cosine x over sine of x, and then power of 2 dx. So let's do first algebra. So we have here now cosine squared x over cosine x. So we have the remaining term of cosine x in the numerator. So we have now cosine x over, that is now sine squared x dx. Okay, so from here, I'm going to rewrite that one as sine x to the power of negative 2 and then cosine x dx. Or I can write here now as u is equal to sine x and du equals to cosine x dx. So therefore, by rewriting that one, it becomes now the integral of sine x to the power of negative 2, and that is just equal to the integral of u to the power of negative 2 and du. In that case, so it's very easy now to integrate. So we have u to the power of negative 1 over negative 1 plus a constant. Then that is now the negative 1 over u plus a constant. And finally, we have negative 1 over sine of x plus a constant, or it could be the negative cosecant of x plus a constant.